chapter 7. I think we only do 3 sections in chapter 7. We'll spend a few days. Was there a knock on the door? Okay, notes out. I just gave you that speech. Come on, Aaron. Guys, come on. So we'll spend a few days on each section just like we always do. If you have a question while I'm going over the notes, please stop me and ask me. That's what I'm here for, okay? If during the homework time you have a question on the homework, ask me. You see me walking around. A lot of people ask questions. Don't just sit there quietly if you don't understand. Let me know that you don't understand, okay? All right, exponential function. The word in there is exponent. So guess what? It's going to have an exponent in it. We've already worked with some of these. This is what the parent function is. F of x equals b to the x. So this is the parent function. Anybody want to tell me what a parent function is in their own words? What do I mean when I say a parent function? Anybody? No? Say it again. Yeah, perfect. Basic function. Where you start. Then we start throwing numbers on it that change how you move around. Okay, so I'm going to talk about that next. But first, let me just identify that letter B. We call it the base. Okay, so anytime I talk about the base, it's whatever this is, and it'll always be a number. It can be a fraction or a whole number, but it won't be negative. Okay, so B is your base, and X is your exponent. Okay, I think we know that, but I'm just going over it. You could even call it a power. Okay. Then like I said, we start throwing numbers on these, like to make it stretch or shrink or move left, right, up, or down. So let's see what that looks like. So A in front, that should be familiar. Let me see something. Let me see how they write it on here. Okay, so half the alphabet has been added to it now, but those variables should be familiar to you. A, H, and K, we've seen them many, many times before. Okay, so I kept in blue that base function, base and the power. So A, H, and K added on do things to the basic graph. So A stretches or shrinks the graph. Remember, we just did this. It was on your test. Brian knows how to do it. Brian knows how to stretch or shrink. He got 100%. I just know he does. Other people probably did too. I just don't remember, but I know for sure if you got 100%, you know. So stretching or shrinking a graph multiplies all the y values. It makes it higher or lower. So I'm going to write that. Multiply y values. Does anybody remember what H does to a graph? Oh, I shrunk it in here. So left or right. It's the H is like, it doesn't stand for horizontal, but you could think of it like that. It's left and right. That is your left and right movement, and it's always opposite. If you remember, a negative H moves you right, and a positive H moves you left. And then there's the K, which of course now we know is our up and down, and it's not opposite. And you'll see what I mean when we get in there. Here's a fun new word. I don't think we've talked about asymptotes in here. Does anybody remember if I talked about asymptotes? Asymptote. It's a really weird word with a P in the middle that's silent. Asymptote. Okay? Let me give you the definition, and then I'll explain it to you in English. It is a line on a graph that can't be touched or crossed. You don't touch the asymptote or anybody else's asymptote. That would be rude. Today is the day that I teach you how to curse in math language. Are you ready? So, I got to think about it, because if I don't think about it before I say it, I will say the actual bad words. Holy shift, look at the asymptotes on that mother function. Mother function. Holy shift. Okay, shift, left, right, up, down, asymptote I just taught you. In mother function, mother is a parent, so holy shift, look at the asymptotes on that mother function. Okay, so now that I've said it, I'll start saying it all the time, like when I make a mistake, I'll be like, mother function, but I have to really think about it. And everyone goes like, I think Brian even kind of looked up when I said that. I didn't get Raja's attention though. Raja, you don't think that's funny? Oh, you are laughing. Oh, are you typing it in your phone so you remember it for later? That's what he was doing, yes. Okay, what is it though? What is a asymptote? An asymptote, like I said, is a line that you can't touch or cross. Think about this. You guys know that you can never have a 0 in your denominator, right? Whatever's on top, this can never happen, okay? So if it can't happen in your math on your paper, it has to be represented on a graph. Because understand, a graph is a picture of your equation. It's a picture. So it has to be exactly matching what the numbers are in your equation. So if you're graphing a line, you could say, oh, I can see my y-intercept, I can see my slope. It should match all the same numbers, okay? So an asymptote is going to be a number that causes a problem for us in our equation, and we represent it with a dotted imaginary line on our graph. So I'm going to show you that here. Now you are sketching on your regular paper right now. If you don't have graph paper, totally fine. Remind me, please, when we get to the homework, if you want graph paper, I will bring you some. Sound good, Evan? Yeah, good. Okay, so here's how we graph these. Really, really simple to graph these, all right? We're going to make an XY chart. And when we graph a line, when we graph a parabola, we just use -2 to 2. The reason we had a special XY chart last unit was because it was a square root. We couldn't have negatives sometimes, so if it was a square root and stuff. But this, you can put any number you want right there. Can I what? Yes. Yes. Anytime. Just remind me, Sarah. I just sometimes don't know to look behind me. Okay? So we're going to use those numbers every time for the parent function. And by the way, this is our parent function, b to the x. There's no h, there's no k, there's no a. This is like the easiest form of the graph, okay? And then you can use your calculator or you can use my little trick here. And always start here. This is where I start, at 0. If I put 2 to the 0 power, anything to the 0 power, do you guys know what you get? 1. So that's always going to be one of your points, 0, 1. And then 2 to the first power would be 2, and 2 to the second power is 4. And guess what? When you put a negative there, it just flips the positive number. So instead of 2, you have 1/2. Instead of 4, you have 1/4. Then you don't have to pick up your calculator at all. And if you did use your calculator and you got a decimal of 0.25, totally fine. You can leave it as 0.25 or change it to 1/4. But that's a quick, easy way to get through your XY chart. And there's no A, there's no H, there's no K, so we're going to go ahead and draw this. Now you might be on the edge of your seat wondering, why did she bring up that asymptote business? Was it just to be hilarious? No, there was a reason. Okay, let's graph the points and then I'll explain where the asymptote is. I'm going to go to the left too, and these are really tiny numbers here sometimes. So just estimate. It's totally fine if it's just somewhere less than 1. Then -1 up a little teeny tiny bit more, and then you have that x-intercept at 0, 1. 1, 2, and 2, 4. Now watch me graph my graph. Look how careful, everybody look. I'm really careful as I get close to my x-axis. Because guess what? I have a asymptote at y equals 0. Why do you think that I cannot have a y value of 0? I'm not going to touch that line. Before I help you answer that question. This graph will keep going ever and ever to the left, hence the arrow, because I can pick any x value I want. The y values will get smaller and smaller to the point, like as I go more negative, the human hand can't graph it. But mathematically, you'll never reach 0. Why? Well, tell me this. What number can I put here that gives me a 0? So what x that I put here will give me a y of 0?
0.
No. 2 to the 0 is 1. 2 to the 0 is 1. There is no number that I can plug in for x. Because I can plug anything I want in. I already told you that. You put any number you want right there. You'll never get a 0. It doesn't exist. It's impossible to get a negative answer when you do exponential functions. Okay? So you'll never reach 0 or any negative number. We represent that with, when it's on an axis, I just highlighted it, but that's a line you don't touch, you don't cross, because this picture has to represent what this represents. Okay? And that is any number you want. That's what the arrows mean, right? Arrows tell us anything in both directions, except we can't go down on this graph. Okay? Let's do another one. So here, I have my B, right? This is B. What letter is this negative for? H. Good. How do you know it's H and not K? Because where it is. H is up in the air, hanging out with the X. K will be on the ground, like this one. Okay? So, guys, we're going to do a XY chart. This should look familiar. I did the same thing when we did radicals. We're going to do an XY chart just up to the X. You don't include the -4. We always use the same numbers. It gets kind of boring. And I'm just plugging in to what I boxed in. Remember my advice? Start at 0. Anything to the 0 power is 1. So your parent function always has that point. Then 1/4 to the first power is 1/4. And when you do 1/4 to the second power, you just square your numerator and square your denominator. And if you need to pick up your calculator for that, that's totally fine. And then you just flip these for the negative. So I'm going to flip 1/4 and get 4, and flip 1/16 and get 16. Now let me tell you, with exponential functions, you sometimes end up with really big numbers. And I don't want you guys to use a whole piece of graph paper to go way to the left 16. So let me show you how you would handle that. Or up, I mean, not go up 16, sorry. I'm like, what? Why? What? Okay, so remember how we graph our parent function. We use x's. I'm still just doing this, and then we'll handle that -4. So I'm going to go to the left 2, up 16, but I'm not really going to go up 16. I'm going to put an x somewhere up there, and I'm just saying to whoever's grading my paper, I know where that's supposed to be. I'm just not going to be obnoxious and use a piece of, because this number can be really, really big, okay? But the whole graph isn't. It's just that one number. Then we're back to Earth. 1, 2, 3, 4, 0, 1, 1, 1/4. Where's 1/4? Who cares? It's a really small number. Where's 1/16? I don't know. Who cares? It's a really small number. That is your parent function. I'm not going to connect it because I'm not done. If you already did, it's fine. It's not wrong to. I just would prefer you didn't. That -4, what is that going to do to all of our starting points? What's that going to do? Right 4. So I'm just going to count. 1, 2, 3, 4, just like we did with every other graph we've ever had to translate. And this will be easier when I give you graph paper, of course. Guys, what's our asymptote? You should almost be able to tell by the graph. Can you see what number, what we're getting really, really close to, but not touching? What are we getting really, really close to? The x-axis, known as y = 0. And I forgot to write that on the last one. So here's what we call it, a horizontal. Why horizontal? Because it's a horizontal line. Horizontal asymptote is y equals 0. Same thing up here. We had a horizontal asymptote at y equals 0. So what we just learned is that whether our base is a whole number like 2, greater than 1, or a fraction, our asymptote was y equals 0. Even throwing in a right or left didn't change our asymptote. You might be able to guess now that what would change our asymptote is if we go up or down. Okay? Here we go. Last one, and then I only gave you 4 to do in your homework, and I'll do some with you. So we start with our parent function. Same, 5, numbers. Isn't it boring? Yes, and we only plug into that point. Remember, we don't do the whole thing. Start at 0. Anything to the 0 power is 1. And then 3 to the first power, 3 to the second power, and flip them with the negatives. It just makes it faster than having to pick up your calculator over and over again. Okay? So, this is going to be, okay. Hope I have enough room here. I'm going to just want another piece of graph paper, because I already drew my line not very straight. Okay. Remember, I'm going to give you graph paper. Okay, so here's my graph. Let's go ahead and sketch those points. To the left, to up a teeny tiny bit. Okay, notice I used X's because that's not my final graph. That's just going to help me draw the next part, which is, what direction are we going to go? No, because we're not up in the air. We're down on the ground at the same level. This is your K value. Okay, look above what H was. H was hanging out with X up in the air. K is down on the ground. This is down 4. Guess what? We get our horizontal asymptote from that number. So our horizontal asymptote is going to be at y equals -4. And to make my graph so much easier, I'm going to go ahead and put it in right now. 1, 2, 3, 4. Okay. I know I'm not going to be able to cross that line. I'm going to move all my points down 4, and it kind of helps me stay in the zone. Okay. So I'm just going to take each of these points and move them down 4. 1, 2, 3, 4. See, I can see. X's I don't connect, dots I do. 1, 2, 3, 4. 1, 2, 3, 4. Oh, 1, 2, 3, 4. And see, having that asymptote there helped me with those little fractions and kept me from crossing. So that's my horizontal asymptote. It's at y equals -4. So if you want to add, and we're ready to start our homework, but if you want to add on to your notes, back where you said asymptote, you can say the K value is what gives it to you. So it was 0 on the other ones. We didn't have one, so it was 0. Okay, let me give you guys a piece of graph paper if you want it. You know what the homework is. We wrote it at the top of that paper, 1, 3, 7, 8. So if you want to start drawing anything, I don't know. Let me give you graph paper first. You guys need graph paper? No? Yep. Everybody got that needed it? Number 1, parent function. Everybody should have this page because we all ripped it out, right? Okay, there's no H or K, and none of the problems you have today will have an A value. We'll introduce that tomorrow, okay? So let's make a XY chart. And we're just plugging into the whole thing, right? There's no H or K. So starting at 0, going down, and then flipping. So flip 1, we get -1, which is 1/3. Flip 9 to get our, and that just makes it nice and quick and easy. Good? We already know our asymptote is going to be 0, y equals 0, because there's no K value, right? There's no number out here. So that means that's my HA. Okay? So -2 up a teeny tiny bit, a little bit more, 0, 1, 1, 3, and 2, 9. I don't know if I hit 9, but I'll tell whoever's grading my paper I know it's supposed to be 9. Just a way of not having to write it all out. And make sure, because when I grade this test, quiz, whatever we're going to have, I will be looking to see if you know not to touch it. Now, I'm messy at times, y'all know. So if you, on like something that I'm grading, you could write me a little note, not touch it, okay? Because it's important to me that you understand what an asymptote is and why it's there. It's because we will never, ever, forever, left or right, have an X value that will give us a 0 or a negative number. We can't cross it, we can't touch it. What's the assignment number? 18. I'll fix it from last year. Notice I wrote it in decimal form this time. Because this was a decimal, I actually just picked up my calculator. It was easier. Okay? So don't be afraid of a decimal. I don't ever take the calculator away from you. Your exponent button, it's called a caret on here. It looks like, okay. That's your exponent key. So I would do 1.5 to the, you said these two numbers? Or any of them? 1.5 to the -2. I just round, I mean, what's the difference between 0.4, 0.44, 0.444? Who cares? It's a teeny tiny number. So I just, you know what I mean? So 1.5 to the -1. 1.5 to the 0. See what I'm doing here? 1.5 to the power of 2. No, look at what you're typing in. Look. 1.5 to the power of 2. Here. Oh, I never knew to do that. That's fun. You find it, Sarah? How do you guys not know where that button is? Come on.